Hi everyone. In today's class, our topic is conducting component level design. Okay, now we are going to discuss about conducting component level design here. Already we have seen what is component level design in previous classes. Now, what are the steps? What are the tasks we are going to learn for a component design here? If you want to make design at component level, then what are the steps or what are the tasks we need to perform to finish off that design or to fulfill that design here, right? Actually, whenever we will start this analysis model, okay, and some architectural model. So there little bit we have finished off the designing part. In analysis model and architectural model itself we have, okay, we had done with some modeling. So what we are going to do, what we are going to perform, okay, in this particular design phase. In analysis phase itself, we had performed some kind of design. The design is called analysis model or architectural model, isn't it? Now that can be transformed or translated into a design model. Already starting of this unit, we have seen that particular diagram. How we are going to transform the analysis model into a design model, isn't it? So now we are in a third phase, okay, designing phase. In this designing phase, we are going to, okay, establish the designs. We establish the design, okay, based on a component here. So what are the components we have in our project? So for that we are going to start or we are going to construct the design. After this phase only we are moving into a coding and testing, isn't it? So this designing phase plays a key role for further phases, right? So the here the design should be perfect, and to complete the design here we are having, okay, some tasks or some set of tasks, okay. So if you'll see those, what are the tasks to fulfill this design is, the first one is identify all design classes corresponds to a problem domain. In first step, what we have to do, if you want to perform a design at component level, then we must go through or we must conduct these 7 steps here. Coming to the first step, identify all design classes. The design classes should correspond to the problem domain here, right? First of all, we need to identify the classes. How many classes we need to represent a problem statement of a project? Okay, after identifying the all the classes related to a problem statement of a project, okay, then elaborate those classes. Elaborate those classes. This and elaboration process we have seen in object oriented view. So this is the first concept in this particular chapter, 10th chapter. Whenever we have started about what is a component, Okay, definition of a component. And after discussing the definition, here the definition would be changed in software designer's point of view. Okay, if you will take at a objective oriented view, then there is a some one kind of definition. With that, here we are having some what one class diagram, how that class diagram would be elaborated in component level design. Okay, till this point we have seen in this the what in 10th chapter. Okay, in component level designing chapter we have seen that. So like that, whatever the classes which are related to your problem statement, first of all we should identify those classes. After identifying the classes, okay, we need to elaborate in detailedly. Okay, in further phases it's impossible to, okay, elaborate such classes. Like that, you should represent the classes in first step. Coming to the second step, identify all design classes that corresponds to a infrastructure domain. What is the second step here? We need to identify all design classes. Those are corresponds to a infrastructure domain. So this infrastructure, actually this is infrastructure domain is not shown in analysis model. This representation is not allowed in analysis model or architectural model. It would be included, this infrastructure domain would be included in design phase only. Right, that is the first point. What is the second point? What is this infrastructure domain includes? This domain includes the graphical user components information, operating systems components information, okay, and also data objects, whichever we are using, whatever we are using, okay, into that particular component design, right? Those are all coming under the infrastructure domain. What is the first one here? The first point is actually the infrastructure domain is not represented at a analysis model. Okay, so it is always included in design model itself. That is the first point. Second point, what this infrastructure domain has includes means it may have graphical user interfaces, okay, GUI interfaces, and how our application is going to interact with the operating system, and how objects are what objects and data are interacting with the classes. So this kind of data is represented, okay, in the second step. We need to identify those, right? See the third one, elaborate all design classes that are not acquired as reusable components. You need to elaborate all design classes, right? So those are not the reusable components. Whatever the attributes we have, whatever the operations we have, okay, those are not reused. If some kind of attributes, some kind of operations and interfaces, whatever we have defined in our project, okay, those are not reusable attributes, then you should elaborate those, you should elaborate those classes, right? And also it must be included, okay, cohesion and coupling, concepts. What is cohesion and what is coupling here? Cohesion in the sense you need to what represent the data members and member functions within a class. Okay, you need to represent the or you need to encapsulate the data members and member functions related to a class. That is a cohesion here. And also coupling is okay, how many number of classes are collaborated with one class. You need to identify the okay in degree and out degree of each and every class. These two designing concepts are also included at this third step. Okay, first step is you need to elaborate the all the interfaces, attributes, operations, okay, which are necessary to implement the class, which are necessary to implement the class. That is first point. Second point is here the component must be considered as the cohesion and coupling states. So these two cohesion and coupling already we have discussed in what this before class itself, right? And that is about the third one. Third point again has okay three. I think not three. It's a four subparts here. First one is specify a message details. Here we need to specify the message details when a class or component collaborate. When a component or class collaborate. So now here we are going to connect one class with another class. Which kind of relation those two classes has, which kind of operation those two classes carrying. You need to mention the message. You need to mention the message in between those two. Okay. For example, assume this is class 1. Okay. This is class 2. Here there is a connection or collaboration between these two classes. So here you should write which kind of relation these two has. Okay, how this particular class 1 is collaborated with class 2 with which purpose? You need to write the message here. Message. For example, you may write like this. It send output. Okay, or some pass outcome. So assume this is one output from one class 1. So which kind of output you may write here itself. Okay, c equal to 10, it is passed to class 2. So like that, whatever the thing, whatever the operation, whatever the relation between the two classes, that relation would specify by using a okay link. That link you should what write the information related to that link. You should provide the okay what is the link specifies that information. This is called message. Here whatever I have written here, this is the output. Output is a message. Okay, this class 1 sends output to class 2, which means whatever the value um is this class 1 is produced, that value is sending to a class 2 as input. Okay, so that kind of things you should return with this link, right? This is called a message. So what is the third a step 3a specifies a message details. You need to specify the message details when classes or components collaborate. Okay, collaboration in the sense they have a relationship with one another, right? So which kind of relation, what is the operation there? You need to write a message like output. Here I have written one message that is called just output. Like that you need to mention. And step 3 step 3 is identify appropriate interfaces. Identify appropriate interfaces for each component. For example, if class 1 wants to talk with class 2, then how these two are interacted with one with another. So communication between two is possible through only interfaces. Already, as we know that the interface is used as a communication connection between two classes, or otherwise in between target system and also a user, isn't it? How the user is going to interact with the application? By using interface, isn't it? So here also you need to identify the appropriate interfaces. Identify the appropriate interfaces, okay, to mean in between the components. If suppose one wants to talk with two, so which kind of interface we need to communicate with this? So you should identify the interfaces, right? So interfaces are the controlled connection between the design classes. It is a controlled connection between design classes here, right? And third C, step 3, right? We'll see the next step 3C. Okay, so this third step, C point, has elaborate attributes and define data types and data structures required to implement them. What we need to elaborate here? Attributes, data types, data. You need to elaborate the attributes and data types, whatever you have used in a data structure to implement. Okay, so this UML, in UML we are having some one kind of syntax or structure to define the attributes and data types within a data structure. Okay, you need to use those, you need to represent those things at this point. Okay, here we are having one kind of syntax. Okay, which syntax is followed by a UML? You need to follow, okay, to represent and the attributes under the data type. What is, if suppose if it is a C, how you are going to define? Data type is a integer, under that attribute name is either a, b, c. These are the attributes, isn't it? Int a, b, c. Okay, like that here also there is a representation, and okay, you should define those attributes. Define those attributes related to a data structure, isn't it? That is the third C. Next, coming to the third D, describe processing flow within each operation in detail. Describe a processing flow. It states that here, if we want to execute, if you want to perform one operation, okay, how it is going to execute in step by step manner. If you suppose if you want to execute one small function, so how many steps that particular function has, how we are going to process those steps, how we are going to follow or process those steps. Here we need to represent, here we need to represent, okay, that processing flow of a particular function, isn't it? For example, if you want to withdraw some amount from a ATM, right? So withdraw is one function within a ATM module. Not only withdraw there, in that particular ATM has provided many services. Okay, withdraw, balance inquiry, and pin changing. Okay, or suppose money transfer. So different kind of services it is providing to a user. Okay, within those multiple number of services, this withdraw is one of the service, which means it is the one of the function here. So if we want to withdraw some amount from ATM, so which kind of steps it is following, how it is processing internally, how it is giving the money to a customer, how it is giving money to a customer. So here we need to represent a process flow to fulfill that particular function. Okay. After selecting the withdraw function, then it would ask how much amount you want to withdraw. After entering that amount, it would ask the next step. Okay, you have which kind of account? It may be a what savings account or current account, type of account. After that, it may be asked you, that will be what, pin number. After that step, okay, once again, it asked you whether do you need a printed copy or not. So here the series of steps, it would ask a customer a series of steps. Accordingly, if the customer is following that instructions, then it is he is processing, I mean, he is go through that instructions, then after that only he would get the amount from the ATM. Okay, these are the series of the steps to withdraw the amount. Like that, if everything is there in our project, okay, whatever the operation we are doing, whatever the which kind of operations, not only operation, it may be a function, okay, related to a function, how it is going to execute that particular function, you need to show in a diagrammatic representation. At this phase, we are going to represent in a activity diagram. Activity, here the example, at this phase you should represent for a function in the in a diagrammatic manner by using a activity diagram, right? So already you know what is the activity diagrams. In previous sessions we have learned, not in detail, but we have learned some examples of activity diagram or state chart diagram. Everything I have explained in previous classes. Okay, if anybody has doubts, please go through that videos, right? So if you want to describe the process flow of a function, then you should take a activity diagrams to represent. Okay, what is the processing flow? So how that particular function will be executing internally or externally, whatever it may be, okay, to finish off that particular task here, right? That is about 3D. And coming to the fourth step, describe persistent data sources and identify the classes required to manage them. What we need to describe here, we need to describe the persistent data source, which means, okay, which kind of storage techniques, storage concepts here we are going to implement in our project. How we are going to store the data of a project, which kind of databases, which kind of files we are going to use. Now in our computer, how are we going to store the data? Okay, so our memory can be divided into four or five A B C D drives. Okay, based on that we may save E drive, C drive, D drive, like that. Always C drive maximum we are using for to storing the apps, and remaining drives we are using for personal purposes. Isn't, we are managing, we are dividing our total memory into a number of parts. Okay, like that here also, if one application is, we are designing one application. Okay, so if any kind of data is generated through a customer or end user, how it is going to handle, how this data is going to store. This persistent data sources also, persistent data sources are also not represented at analysis model level. Okay, this can be represented at this design phase itself only. Okay, in designing phase only, how the data is going to be stored, our project data is going to be stored. Okay, which kind of data, it is a software or it is a any kind of data. How we are going to describe the databases, how many number of databases, what is the capacity of those databases. Okay, so if you want to retrieve the data, how it is possible, if you want to store the data, how it, everything, okay, related to a storing of a data related to one project would be describe at this describe in design phase. That is the fourth step. And also you need to identify the classes required to manage them. If you want to store the data into the databases, how you are going to store, which kind of classes you are going to use to store the data. If you want to retrieve the data, okay, which kind of function or classes used to retrieve the data from memory. So you need to identify those classes also. Okay, that is the organization of data into a memory of a project. Next, coming to the fifth step, develop and elaborate behavioral representations for a class or component. Okay, at this step, what we are going to represent? Behavior. Okay. You need to develop and elaborate the behavioral representation of a class or component. Okay, in general terms, if you want to represent a behavioral things, we must use the use case diagrams, which means if one customer is there, how this customer is going to interact with a target system, how we are going to shown by using a use case diagram, isn't it? Not only a user, it may be a technical person or it may be a uh, developer, anybody. Okay, how those persons are going to interact with that particular system. Okay, we can represent by using a use case diagrams, behavior of a human being with the system, or one component with another component, like that. Here we are discussing about a behavior. Okay, in top level, the behaviors of a user, a client with the system would be represented by using use case diagrams. In architecture level model or in analysis model, here we are going to describe a use case diagrams for representing a for representing the behavior of a customer with the system, right? Okay, at this level, in in this level, we are going to use the state chart diagrams. State chart diagrams to understand the dynamic behavior of an object. In top level, just as usual, we are using that use case diagrams itself. Okay, but in component level, whenever we are going to in detailed manner, then we are going to use a state chart diagrams here. Okay, so how the transition from one state to another state. Okay, we are going to represent by using a state chart diagram itself. Already you know that how that state chart diagrams are drawn, and symbols we have discussed, even symbols also about those state chart diagrams. Okay, if you have idea, it's okay. If you don't have idea about that, okay, better refer that previous classes, right? This is the fifth step. In this fifth step, we are going to discuss about a behavioral representations of a component, right? Component or class. Coming to the sixth step, elaborate and deployment diagrams to provide additional implementation details. What we are going to elaborate here? Deployment diagrams. Deployment diagrams here. So what this deployment diagrams, okay, represents in the sense location of key packages. Whatever the packages we are having, packages in the sense it may be under one package we may store a collection of classes. Okay, so these are the number of packages we are using in this particular component level diagram, isn't it? So actually where these packages are stored in a computer, it's called location of a key packages. Location of a key packages are need to show. So which means that the specific hardware and operating system environments. So these are the specific location of a components packages. Specific location in the sense, I mean what is the hardware and what is the, okay, operating system software components, where we have exactly located these packages, how we are going to extract that after using of that, after using that particular package, how we are after closing that again, okay, how it is going to store into a into that particular application. So like that we need to represent some additional implementation details, additional implementation details by using deployment diagrams here. Here we are having deployment diagram representations also. At this deployment level representations, we are going to show the additional implementation details. Additional implementation details in the sense the package details, packages, how many packages we have used into our um, design or project. Okay, actually where those packages are stored, are located into that particular project. Location details of a packages. A package is a collection of classes, right? So this is about sixth step here. And coming to the last one, uh, factor every component level design representation and always consider alternatives, which means refactoring. Okay, so first of all, not only one representation here, better we will take two or more, I mean one or more representation for every concept. Why? Because if one is not suitable 100%, then we are going for some other alternative one. Okay, okay, why are we carrying stepney with us if we are going some what trips, right? So if we are going for some outstation trips, okay, we may take with us one stepney, right, tires or something. Why are we carrying those? Okay, if anything problem, if we got any kind of problem with that particular tires, we may change that, right? So like that, here also we are having some alternative architectures, I mean alternative designs for a particular project. Why? Because if one is not 100% suitable to that particular project while implementation, better we may go for a second one. It's impossible at that time. Here you need to start again one more design, isn't it? You are at the implementation stage, coding stage. That particular design is not not providing accurate results. Okay, not providing accurate results, then better we'll immediately we'll choose some other design, and we will implement in that particular manner. Instead of doing that, suppose at the time the designs, alternative designs are not there, means our work is going to stop at that stage for few days. It's a time waste process. To avoid that, better we may, okay, put one or more alternative solutions or design solutions for a problem. Okay, some design techniques are suitable only for at that paper itself, not any practical nature. Okay, that's why this is refactoring, or refactor every component level design representation and always consider alternatives. This is used as a alternate for us, right? So these are the seven steps or seven tasks while developing a component level design. You need to follow these seven tasks. Okay. This is about conducting a component level design. Next class we are going to discuss about some component level design at web applications. That is our next topic. uh, at this at this particular topic, we are having some diagrams, collaboration diagrams, and see, this is the representation of messages. Okay, some collaboration diagram and refactoring diagram, activity diagram, state chart diagram. Okay, in some points we have discussed about the state chart diagram and also activity diagram, collaboration diagram, everything. Okay, if anybody have doubts, you can go through these charts. I mean, go through these diagrams also. If you have the time, you can go for, if you can go and listen the previous videos. Otherwise, but in below slides itself, you are having some diagrams. See, this is the conduct of a component level design. So after that, you are having some diagram. You can go through this, right? This is the next concept we are going to discuss: component design for web apps. Okay, in this particular fourth unit, we are having more 2 3 concepts. Okay, then after that only we are going to learn fifth unit, right? More 2 or 3 concepts are there in this fourth unit. Okay, after finishing of those concepts only, we'll move to the fifth unit, right? Okay, now I'm going to stop the class.